Today we will start with our remaining topic of the first lecture. So it was we have discussed about the disadvantages of the file-based system. Okay, so the first disadvantage was the data redundancy and inconsistency. So we already know about that. Redundancy means that there will be a duplication of data, and inconsistency means that when we delete the data from one particular table, it should all be deleted from the relevant tables as well. Okay. If this particular thing happens, there will be no inconsistency, but in particularly file systems, this particular system will be present. Okay. Another one is difficulty in accessing the data. So again, we need to write every time a new program uh, to uh, to access the data. So that is not feasible in systems as well. Another thing is data isolation. So we have multiple files and formats that are present there. So it can be taken care if we have only one particular format. DBMS provides this particular functionality that it takes all the files and convert it to one single format. So it will be easily accessible by the software. But in file-based system, that there can be different files and formats that can be present, so it leads to a little bit of a ambiguity in a system. Okay. Another thing is integrity problems. So integrity constraints that are not specifically designed. uh, First of all, there are very less low there are very low less number of integrity constraints that are present in file based system. And another integrity constraint, like that the count balance should be greater than equal to 0, became buried in the program code rather than being stated explicitly. Okay, so if you have coded this particular thing, it will not be visible, or it will not be, what you say, obvious. Okay, so you have to search for it, you have to look for it, you have to take a look at the code to understand that this particular thing is written there. Okay, however, in DBMS, this particular constraints, different constraints are already defined. Okay, so there will always be some kind of a unique feature to a particular constraint that you will get to know about those features. Okay, so if I suppose if I want to use a constraint like not null. Okay, so it is very easy to understand. It says that you cannot enter null, or you cannot leave the row, or what you say, a column or a row empty. Okay, so that particular constraint denotes that, but it is not possible in file based system. Okay, with this particular thing, there are so many constraints that are already and readily defined in DBMS, that is not present in file based system. Another thing is atomicity of dates. Atomicity means that there will be all or nothing. Okay, so there will not be anything in between. Okay, so if there is a failure in the transaction, uh, it should be reversed. Okay, but this particular thing is not possible in file based system. Okay, so suppose if you're transferring some money to your friend, and you have 100 rupees and you are transferring 50 rupees to your friend. Okay, so what happened, you when you transferred 50 rupees, your 50 rupees, your account is updated. But when it is reaching to your friend, suppose the transaction failed. Okay, so actually what should have happened, that your original balance should again have rolled back to 100. But this particular system is not available in file based system. Okay, so this is available in transaction processing, that is available, that is a part of DBMS. Okay, so again, atomicity of updates is not possible, or it is not very much there in file based system. Another one is concurrent access by multiple users. So I think I have given you an example. So when there are multiple users accessing the same data, there may be inconsistencies in the data. Okay, so suppose the example is given that two people are reading a balance, say 100, updating it by withdrawing money, say 50 at the same time. Okay, so this particular thing is referred to as concurrent access. Concurrent means at the same time, when a multiple users try to access the same thing, that is one thing. Another thing is there would be many security problems. We already know that, because the features that are provided by DBMS are the security, like grant grant and access, revoke commands that are not possible in file based system. Okay, so database system, that DBMS system, offers the solution to all of the above problems. So whatever is the disadvantages of the file-based system is the advantage of the DBMS. Only file-based system advantage that does not have, that do not have, that is not there in DBMS is that the processing speed of this particular system is faster than DBMS, because there may be operations involved in DBMS for a particular but if you want to bring out a particular row and a column, that is not there in DBMS. Okay, that is not there in file-based system. Now keep in mind that there is something called data isolation. Now what is the meaning of it? There are different meanings in transaction. The data isolation meaning is totally different than here. Okay, so here just remember that data isolation here means that there will be a scattering of data, means that the data is spread throughout the hard drive. Okay, so in transaction the meaning of data isolation is totally different. I will tell you when I get to the transaction part. Okay, so don't worry about that right now. So understand this particular thing. But I have told you that remember that relational means whenever there is a relational part, there it is the meaning of this is table. Okay, first of all remember this thing. And in DBMS there is something called a row. Okay, so this row most probably will be referred to as something called a tuple. Okay, so in DBMS row is referred to as a tuple. So it's a fancy word, but it's the same thing. Okay, so just wait a second. Okay. So just remember these two words, and there will be many more words that I will tell you about. So don't worry about that part. Okay. So whenever you are reading the book, for your reference that I'm telling you, because in books they always use fancy words to confuse you. Okay. So relational, just to remember. So relation here means always means table, and whenever you see a row, this particular thing is referred to as a tuple. Okay. So it's a fancy word, but it's one and the same thing. Okay, so in other word, whenever there will be another difficult words that come, I will try to explain each and everything in simple ways. Okay, so now just a little bit of a thing that how particularly your DBMS works. Okay, so we already know that in if you remember the student example that I have given you, that in the student part there are three departments here. The first department belongs to admin, another department belongs to I think accounts, and another department belongs to hostel. Okay, so every in file-based system, every particular system has its own data. Okay, so actually how will a DBMS works? I already told you that if you see here the admission parts will have some. Okay, so I'll write it like that so you understand. So I'm writing it that what are the fields that are available in admissions administration part. Okay, so there will be name, roll number, class, and one more field that will be interest. Okay, so in particularly in account field, there will be again name, roll number, class. One more field will be what is the fees that is related to your course, and I think that's enough. Okay, so there may be another field, but I do not need to worry about that part. Okay, so the different field in accounts in admin part is your interest, because based on the interest, the placement will be done. Okay, in account field, there the different field is fees, and in hostel, again you can also add scholarship part as well. Okay, so how much scholarship you got, and that particular amount will be deducted from fees. Okay, so these two columns are different than the other that is specific to this department. In a similar way, Hostel also contain name, roll number, class. Another field can be hostel fees, your mess fees, that part will contain. Okay, the different row will be the different what you say, the different column here will be hostel fees. Okay, so in DBMS what happens is that we know that there is a problem of name, class and roll number. So what can happen is that again I combine this in DBMS system. What will happen there is that you see just wait a second. What will happen here is that I'll do that there will be a database. First of all, the database will be something like student record database. Student record. Okay, so everything listed here. What is the name of the student? What is the class? What is the roll number? Everything will be available here. Okay, so other departments like your admin department and your accounts department and your hostel department are sharing this particular information by, again they have their own columns also, like the hostel fees, that will be a different column. Sorry, what is the column here? That is your interest field. Okay, so what happened here? Okay, so the interest field that here will be different. In the similarly in account field there will be your fees or your scholarship, that will be different. And in hostel part there again will be some different field that is not available there, that is your hostel fees. Okay, so if you're seeing here the redundant part of the tables here, that is name, class and roll number, can be easily accessed from the student record. Okay, so there are various operations that are available in SQL. I'll tell you about it, and or not, something like that. Okay, so you will be able to access only a specific part. Suppose if I want only hostel students that are there in the hostel part, I will be able to access from this particular field. Okay, so suppose if I add here one field that a particular student is a day scholar or a hostler. Okay, so based on this field I can easily separate the hostler students and I can take the name, class and roll number from there. Okay, so you can add more and more information in the student record field in this particular table, so that you can easily access it in different departments as well. Okay, so whenever you are building a common table, always try to add as much information as possible. Okay, so I'll show you how can you do that. Okay, so I the hostel fees, I only need the fees of a particular student, that I can take this particularly from this student record table, and I can just do a Cartesian product or something. I'll show you the operations, don't worry about that right now. And I can change the table to something like this. Okay, where name, class and roll number will be accessed from this one, and the hostel fees will be specific to this particular department, that can be added by using a single row. Okay, so that is the beauty of using a DBMS, that you do not have to create a redundancy of data. So one of the most advantage, what I can call the one of the biggest advantage of using a DBMS is that there is no duplication of data. With no duplication of data, there is so much storage that is saved. Okay, so again, if you are if you are uh, if you are in computer science, you already know that there are only two concepts in computer science. Okay, so everything is based around in CS there are two things. Okay, the first thing is how to save time. Okay, so that you will learn in your algorithm part and your data structure part. Okay, and another thing is how to save storage. Okay, so most of the different kinds of storage data structures are also available. So all the CS all computer science subject will be based on these particular things, that how can you save time or how can you save storage in a particular thing. Okay, so DBMS is particularly related to time as well as storage, both of the things. Okay, so I'll show you the time. There are some operations that take less time as compared to other operations as well, so you can also save some time with respect to storage. Okay, so redundancy is one of the biggest thing that what you say that made us to move towards the DBMS part rather than to stay in the file based system part. Okay, so this is just a simple example of how DBMS actually works. Okay, this file-based system example is given. I already told you that every particular program will have its every particular what you say storage system. So that is file-based system is something like what you say a personal thing. Okay, so application system we will have its own file system, application system and its own has its own file system. Okay, so that is the biggest difference between DBMS and file system. Every application program will have its own file allocation system, but in DBMS this particular thing is shared across all the departments, or you can say all the application programs. Okay, another thing, this is again a little bit of example of file-based information system. If you are seeing here, the customer number is also present in invoice. Customer information is present here. Your four fields are there, and if you're seeing here, customer number and customer name also appeared in invoice. And another thing is part number is appearing here. So I think that is fine. Okay, so part number one field do not take anything, but if there are two or more fields, that will be a problem. Okay, so part number and unit price, if you're seeing here, part number and unit price is again repeated here. Okay, in the similar way, if you're seeing here that there will be an inventory that will be related to part, again the part number part is repeated here, and the supplier part is repeated with respect to this, and the quantity order is also repeated. Okay, so all of this, if you're seeing here, there will be a little bit of a repetition in every table, but this particular thing can be avoided. Okay, so I'll show you how can you avoid. We will take different kinds of example that will show you that how easy it is to use the tables on the go. So that is one of the biggest advantage of DBMS. Okay, so just this is some examples of file-based system. Okay, what is actually the difference between file and DBMS based system? So it is a software that manages organizing in a storage medium within a computer. Okay, so that is why I've said it is a kind of a personal thing. In a similar way, it is a software for managing the whole database. Okay, so again, it can be available in the system, but mostly it will be like the data will be shared across the machines. Okay, so this is one of the beauty of DBMS. Okay, so if you are in a company, what will happen that there will be some common part that will be accessed by all. Okay, so your files, your records will be taken care of by the company DBMS software. Another thing is redundant data can be present here. There is no redundant data. It does not provide backup of recovery, but here the backup and recovery is available. Again, there is one feature. Another thing can be that it does not have any transactional processing system. Again, DBMS has a transactional processing system, because if the data is shared across different users, so I have to make a transaction system to deal with the concurrent access problem. Okay, so if you're seeing here the concurrent access problem, that is the solution of the concurrent access problem that is given by DBMS is also used by OS. Okay, so if you have a OS subject, operating system subject, you will see the same solution also working in OS. Okay, so in computer science, whenever you see one solution to a problem, that particular solution is also applied across subjects. Okay, so I'll show you if in the coming subjects you will be able to easily verify that when you are reading concurrent processing also occurs in OS, operating system, and you will see that there will be something called inter-process communication. Okay, so when different processes are accessing a same variable, so again you have to do something called a concurrent part. Okay, so this is again a concurrent problem that is also taken care by the same way that we take care of this particular problem in DBMS. Okay, so if you learn one solution, it is applicable to across subjects as well. Okay, so I'll show you I'll tell you about the solution of this concurrent problem. I'll also show you how it works in OS if I have time. Okay, there is no efficient query system. There is a efficient query system. Query means that you can there are limited queries available, like the integrity constraint that I've told you about. This particular thing is not available in file based systems. Okay, there is less data consistency is very much high because of the process of the normalization. Okay, so I'll tell you, there is two particular concepts in DBMS. First is the ER diagram, and another one is normalization. So these are the most important concepts of DBMS or IMS. If you understand this, you understand the whole DBMS. Okay, so mostly it is based on these two particular concepts here. Okay, so I'll tell you about normalization and DBMS ER diagram in complete detail. Don't worry about that part. Okay, it is complex as compared to DBMS. It has more complexity handling as well as compared to file system. So we already know, because the DBMS has something called operators, and we have to take care of lot of things at once. Okay, so if there are many people accessing the same data, so again we have to take care of it. So DBMS is a much more complex system than a file-based system. File-based system is pretty much straightforward. Okay, so again it has security mechanism that is available to it, but file-based do not have any kind of a thing. Okay, so it is not expensive. So these are expensive software. Okay, so Oracle is one of the biggest company that supplies their this software, and they charges, I think they charges normally, but this this Oracle company is one of the biggest company, and they made their software is sold, I think, everywhere. If you take any product based company, they will always have a particularly DBMS system employed, mostly by Oracle. Okay, so this is proven thing. Okay, so another thing is that what we have studied so far, this is just a little bit of a cautionary, so that you have understood anything that we have done. Okay, so the first question is data isolation caused due to dash in traditional file system. Okay, so can anybody answer? Just
Scattering of data.
you can just write in chat box. Okay, so I got the answer as 2, scattering. That is good. That is the answer. Okay. Data isolation is caused due to scattering. I already told you scattering means that in in concurrent processing, the meaning of data isolation is totally different. But in traditional file system, this is referred to as that your data is scattered throughout your hard drive or your HDD. Okay, so the answer for this one is scattering of data. Okay, so one is, if a person A wants to transfer fund of 500 to B, if failure occurs after removing 500 from account A before transferring to account B, then the problem caused is, I think I'm giving you the same example. Anybody? Just write it in chat box. Yeah. Good. Yes. This is atomicity. Okay. So if you remember, all or nothing, all or nothing. Okay, so if there is a problem, it should be that when you are transferring the data, it should be that the changes should be rolled back, but in file based system it does not happen. Okay, so there is something called a partial update that happens in file based system, but in DBMS this particular thing is taken care by the software. I'll tell you how this particular thing is taken care by the software. So the answer is data atomicity. Another one is duplication of data at several files is called as, I think you already know the answer to this. We have discussed this so many times. Duplication of data. Yeah, absolutely right. Okay, so this is referred to as redundancy. Okay, so whenever there is a duplication of data, that example I've given you, name, roll number and class, this is particularly referred to as data redundancy. Okay, is if in a redundant file common fields are not matching, then it results in data isolation, data redundancy, data integrity, inconsistency. Okay, so what will be the answer? If in a redundant file, it is saying that if in a redundant file, so suppose this is a redundant file, here there is some field like A, B, C that is there, but same files a.csv, a.csv, suppose. Okay, so these are the same file, but this particular field is not there in this particular file. Okay, so what will be the answer here? Okay, So this particular thing will be referred to as data inconsistency. Okay. So if these are the same file, if one column is there, another column should also be there, because if they are the same file, the same entries should be there. Okay. So if they're saying if in a redundant file, common fields are not matching. Suppose these are the common fields like name, roll number, common field. Okay. So if they are not matching, this particular problem referred to as data inconsistency. Okay. It is difficult to access conventional file system than database. So this is very simple. It is true, because conventional file system is do not have any kind of a feature. Okay, so this question is an interesting one. Can you tell me the redundant field here? Okay, so which of the following information is not redundant? So these are the columns that are given to you. Which of these 1, 2, 3, 4 is not redundant, not duplicated? Take a look at it. Okay, so what happens, there is a saving account and there is a current account. Okay, so in saving account your salary part comes, and in current account your reimbursement part comes. Reimbursement means that you have gone to a company trip, and yeah, you paid the bill and you gave that bill to company so that you can be reimbursed. Okay, so current account is that. Okay, so that is definitely correct. That account number here, the account number of current account and saving account will be different. Okay, so these two particular particular columns, like I'm always saying column, but you when I'm saying column, just remember I'm trying to say fields. Okay, I just use columns interchangeably with fields. Okay, so because what happens in a table, this particular thing is referred to as a one field. Okay, so I say this particular thing as totally column. That is not correct. Okay, so remember this particular field that is referred to as account number, that will be different, because no two account number should be same in a bank account. If so two, it is like saying that two students have the same roll number. If two students have the same roll number, there will be different kinds of problems that will occur. Okay, so the answer here is account number. So another cases that are given here, that is what are the different kinds of companies that are using different kinds of data. Okay, so you can read about it. These are some simple case studies there. So different companies like Amazon and different companies like Google, they also employ like different what do you say, MySQL languages to sort through the data. Okay, so another advantages of it I'll tell you about when we came into it. Okay, so there are three aspects of studying DBMS. First is modeling and designing of data. Okay, modeling and designing of data, that I'll tell you about, allows exploration of issue before committing it to the implementation. Like I already told you that if you remember, I told you that whenever you are trying to build a database, uh, if you have to build something called tables. Okay, so before building tables, you have to build something called entity relation model. Okay, so if you are able to build an entity relation model, that model can easily be converted into tables. Okay, so that modeling part will comes under this particular thing that is referred to as ER diagram. Okay, so design of database will also come under, there is some bottom up approach referred to as normalization, but I'll tell you about it. Okay, another thing is programming. Three aspects is, first one is modeling, if you are able to design tables, and then you are able to perform queries on the tables, and then there is the implementation of the software that we are talking about. Okay, so that all these two aspects will be done in the lab, so don't worry about that part. Okay, so this one will be done in the lecture. Okay, okay, so just look at this. These are for your own benefit, that you just, these are some questions that are asked by us, that which of the particularly RDBMS, big companies use RDBMS. Okay, suppose does Facebook, Alex, just wait a second. Stop. Okay, so these are some tasks, you just read about it. Okay, so Facebook also uses RDBMS, but which kind of RDBMS and how actually the data is stored. Okay, so if you are if you are studying Python, you may have heard about something called JSON software, JSON language. That particular format is used to store data as well. Okay, so there are different kinds of format right now, but do they use RDBMS or not? Okay, so RDBMS again. I'm telling you this particular thing again. R here means relational. Okay, so when I am specifically using relational DBMS, I'm talking about tables. Okay, so if the DBMS software is applied in tables, okay, so just look for it. It's a simple Google search, but you will see quite interesting things if you just do a Google search regarding these things. Okay, ahead with the architecture. Okay, so I think, yeah. Okay, so moving ahead with the architecture of different kinds of databases. This is just the first, only this part is a little bit theory part. Okay, so the first is basically an introduction. You already know that this has to be theory because you has to know about that what you are going to read and how it will be relevant to you. Okay, second part, the architecture part, is again a little bit of a theoretical part, but after that, when diagram comes and your normalization part comes, your database system become whole lot interesting. Okay, so one thing that you understand, that if you are able to understand diagram and normalizations, okay, so if you understand both of the things, your half of the database is done. Okay, so the remaining part will be your transaction processing system, and one part that will be covered there was queries, that will be covered in that. Okay, so if you understand and normalization, these are the most important topics of DBMS. If you understand these two topics, I think half of DBMS is already done. Okay, but before understanding these particular topics, you have to understand that actually what is the architecture and why we are using a table based approach rather than other approaches. Like, you can easily if you see a linked list, in linked list what happens is that your table this particular, you can store your data here, and this particular field will be your pointer, that is referred to another linked list. Okay, so you may be thinking that why we are storing the data in tables, why not in linked list, why not in stacks, why not in queues, why not in any other different data structures that are readily available. Okay, so you have to know about these things that will be covered in theory part. Okay, so first of all, the just wait a second. Okay, so I think you have already studied this particular part in Python or Java as well. So what is the data abstraction means? So abstraction of data is hiding the irrelevant details. Okay, there is something called a naive user. Okay, so naive users are those users that are pretty much the dictionary meaning of naive is straightforward. Okay, so it means that these are those users that do not care about the implementation, that only care about the user interface. Okay, so if I am able to understand or if I'm able to use your application, that whatever you have developed, I do not need to care about that what lies under it. Okay, So what is the meaning of it? If you are saying that the user interface should be so much interactive that I do not need to worry about that what is the working of this software. Okay, so naive users are not concerned with how it is programmed or how you have done it. Okay, we the naive users are only concerned with the using of the application. Okay, so all the applications that are you using on your mobiles like your Facebook, your Instagram, you are not concerned with how your data is stored at the company's end. You're not worried about that when you search, when you list, when you just go hunt and search a particular person on Instagram and Facebook, there are so many algorithms that are going in the back, like graph search and many other searching and sorting algorithms that are going in the back, but you are not concerned with the algorithms. Okay, so data abstraction is that part that hides right relevant information from the user so that the users does not get confused. Okay, so we do not want to confuse users, we just want them to enjoy the application. Okay, so whatever you have developed, the users have the right to enjoy it. Okay, so you have to make the things so simple that naive users that are not concerned with how your data is stored, how search is going on, how everything is going on, it is not area of concern. Just you have to give the users a little bit of options so it can easily sort through your application whatever you have developed. Okay, so database systems are actually made up of very complex data structures. Okay, there is one particular data structure like B tree or B plus tree that are relevantly used in databases. Okay, so this is again indexing data structure. I'll tell you about when we reach there. Okay, so this is specifically very useful to DBMS. Again, you can use it for any purpose, but these are very much useful in databases. Okay, so B tree and B plus. Now you already have studied about other data structures like linked list, uh, other many other data structures. Okay, but structures in C's, structure in C, etc. Okay, so this B and B plus trees you may not have studied about it because this is very relevant in databases. Okay, so particularly people do not use these kinds of data structure. Again, this is a very complex data structure. There is a lot of things going on in this thing, that is why it is not generally used. Okay, so it is like a linked list, but it is like a doubly linked list and it has additional features also. Okay, so when you are going to read about data structure subjects, you will get to know about these things. Okay, now, now to ease the user interaction with the database, that developers hide the internal relevant details from the users. We already know this. If you are a developer, you will try to hide the relevant details so that the user do not find the application intimidating. Okay, so you do not want everything in the hands of user. Some things that little bit of a customization, but everything will be done by the developer side. Okay, so that is why this particular thing is divided into three levels of data abstraction. Okay, so another thing is that we divide these three levels in order to achieve data independence. What is the meaning of independence is that when you change there are three levels here. When you change this level, physical level, it should not affect the upper levels. Okay, so if you change this particular level, it should not affect this level. Okay, this is referred to as data independence. Don't worry about it, I'll come into that. What is the meaning, what will be inside these boxes, don't worry about that right now. Okay, now what are the level of abstraction? So this particular level of abstraction is referred to as user level, external level, view level. External level, view level is already there. Sometimes it is also referred to as user view. Okay, so again it is like the naive users that are directly using your application, that can also be referred to as. Okay, so a particular user can change little aspects of the application but not everything. Okay, so suppose if you are developed application, I can change a little aspect, like I want to see the date in DDMM YY rather than YYY mm and d. Okay, so these kinds of thing the user can change. Okay, so there will be little bit of a customization for the user, but not that much. Okay, so that is referred to as view level. Okay, so what externally, this is also referred to as external view, that what a particular user can view it. Okay, so that depends upon the developer, that how developer is coding the application. Another thing is application. Okay, conceptual, this is also referred to as logical level or conceptual level. Okay, internal schema or physical level. Okay, so internal schema and physical level, this is the, what do you say, the bottom part of the level, and here all the data structure and all the things that a developer is dealing with will come here. Okay, so everything that physical levels mean that you are, what you are building, when you are building the application, you are dealing with programming everything. You're not concerned with GUI, but you will be building the GUI. Okay, so the graphical user interface you will be building. So everything, programming, data structure, and other things will come into that. Conceptual level is a little bit between these two things. You will be, you will not be like that you will be dealing with data structures, but here it will be saying that how your data is actually stored, something like that. Okay, so I'll show you one by one. So the physical level, this is the uh, lowest level of data abstraction. Okay, so it describes how your data is actually stored in the database. Okay, so how your data is actually stored, what actually, what date, because we are talking in the we are talking in respect to databases. So I cannot say that when I talking about the what do you say, the application, I was showing, I said data structure and programming. Actually we are talking about in databases. So how the data is actually stored in database, so that will be that what actually how your data is storing, which particular data structure are you using, that will come in the data physical level. Okay, so like data structure, like indexing method like b plus trees or hashing and access methods, whatever you are doing, it will come under this physical part. Okay, so whatever is the implementation, how your data is actually stored. In conceptual level, what data is stored you will be able to view. Okay, so what data stored means, you will not be able to change the uh, database methods. Okay, so if you're using, if you have used b plus in the implementation, you will not be able to change this, but you will be able to just see what kind of data is actually stored. Okay, so without knowing the implementation detail, but like whatever, what the data structure is being used, what are the tree implementation that is used. Okay, so this different this level also tell us about the relation between different fields and database table. Okay, so it will also tell that this particular table is linked to that particular table. How? Okay, so that link will be established by the physical level. Okay, keep that in mind. The physical level is like that you're coding the problem, but not actual coding in a way, because we are talking about in the way of in respect to databases. So it will be like that how you are storing the data, how you are actually storing the data in the database, which particular methods are you using, which particular data structures are you using, which particular methods or indexing methods to access the database, uh, uh, the user can access the database will be defined in the physical level. Okay, so what is the meaning of it? That suppose you have made the databases, there are many databases using b plus tree or any other data structure. Okay, so these are stored there. Okay, so now as a naive user I want to access any database. Okay, so I'm not concerned that how actually the data is stored, I just want to access the database. Okay, so whether I was able to access it sequentially or I can do a random access, that can also be defined in a physical level. Okay, so this is again an implementation part. If you're seeing here, the implementation will come in physical level, and and a little bit that what data is stored. You can see little bit of details, but not all the details. So this is like a mid level. You can see the little bit of details that what data is stored, but you will not be able to see all the details. Okay, so the view level will be your external level. You will not be able to see any kind of a detail. Okay, so this particular level is decided by the physical level engineer, that this particular user will be able to see how much relevant details will be defined in this one. Okay, so this is the highest level of abstraction also. from 3 levels of data abstraction. In this, only the part of the data which are relevant to the users is accessible. Okay, so suppose if you are a student, you will be able to see your relevant data, so like what are the lectures you're going to attend, what is the timetable that is related to your semester. Okay, so if I'm a teacher, I will be able to see my relevant data, like what are my lectures that I will be going to take, what are the timings, what are the free timings, so that I can access another things, like I can take a meeting rooms, what are the meeting rooms timings, so that I can take any meeting with any colleague or any part of the organization. Okay, so that particular relevant detail will be what you say relevant to me. Okay, so that is why we are seeing here the view level will differ for different particular different roles. Okay, so teacher will see different things, student will see different things if the data is regarding the college management system. Okay, so that is, but part of the data is seen by a specific application will be defined at the physical level, but actually what part you can see is given in this. Okay, so you can only view, you are not able to see what data is stored, you are not able to see how data is stored, but you will be able to see the data, only data. Okay, so you're not concerned with any other details. Okay, this is also referred to as, so the end user or the naive users are the external view or external level. Another thing is the programmer can be say the conceptual level, the programmer there will be a little bit, you can design a schema, another thing, short small thing. Okay, there will be your database administrator. Okay, so how the data is stored, what methods to use, the administrator will define the internal or the physical level. Okay, so there are so many names here, so I'll just list out the names: logical level, conceptual level, internal level, physical level. I think there is one more name here, physical level. Yeah, physical level, internal level, conceptual, this is logical, also referred to as logical level. This is external or user level, user view you can also call it. Okay, so these are the same names for the same design, if similar design. Okay, now till here, if anybody has any question, just let me know.
So what was DML in the previous slide? So DML in the previous slide. So the first
DML.
level. I mean the third level.
Hello.
Yes, sir. DML.
Email. Okay. So actually, this is data manipulation language. Okay. So in this, there are different kinds of language like create table, alter table that comes with it. Okay. So as a naive user, so I will be able to access some parts of it, not all. Okay. So if you're seeing here, this enables us. How can we do it? That you want to create a table, you can easily use a GUI application to do that. Okay. So this is a DML that we are talking about in labs. Okay, so if you have attended the lab, I think we have. Okay. Okay. So any other question? Okay. So now this is a little bit a good example that make you understand that how actually this levels works. Okay, the physical level is again relations. Relation means that it is talking about tables sorted on unordered files, like the index of first column of the students. Okay, so if you remember that whatever is a student table, whatever is the index like student name, roll number, whatever it is, you are designing that how the data will be stored in tables. Okay, so that particular things comes under a physical schema. Now the conceptual schema will be that the student, what is the data type of it, you can define these particular things. Okay, so the name here, string, login that I'm using is string, age can be used as integer, something like that. Okay, so that will come under your conceptual schema. Okay, so you are defining the tables, and the data structure regarding to the data type regarding that table can also be defined in a conceptual schema. And external schema, that you can easily able to view the tables that are already stored there. Okay, so with some commands, I'll tell you in labs that how can you able to use some commands. Okay, this is again a little bit of an example of data abstraction. If you're seeing here in the external view, you are just seeing the information. Okay, so if you're seeing the course information, you are seeing the student information and whatever is stored in there. Okay, so in conceptual schema, you may be able to use student table. If you're seeing here students, and you can be able to add something. Okay, so if you are if you want to join this particular student table with courses, you may be able to do that. Okay, so I'll tell you different commands to do that. But in physical schema, you are actually building the tables, and how a particular what is the access method, may it be randomly accessed or it will be sequential access, that is defined by the physical schema. Okay, okay, so another thing is schema and instance. So I think I'll discuss this one in the next one. Till here, if you have any doubts, just let me know. Okay, just remember simply that physical is that how your data is stored, and conceptual is what data is stored. Okay, so user level, we already know that how the user will be viewing the data, that will come under the user part. Okay, so three level of abstraction, also referred to as the architecture of different models. Okay, so any doubt, you know what to do. I think that is enough for today. I'll continue this. Only a little bit of a part is remaining, so I want to continue that part in the next one. Okay. Any doubt, let me know. Any question that comes into your mind. Any question. Okay.
No, sir.
Okay. So thank you for listening, and you can move on to the next lecture.